Hi class! In this video tutorial I'm going to talk to you about permutations and combinations, which are called counting principles. So the first example I have here is how many ways can a bike lock of 3 numbers be set if the choices are 0 through 9 and the numbers can be repeated. So for example, a bike lock could be 1, 2, 3, it could be 3, 2, 1. That would be a different combination. And so what we're doing is we're counting the number of combinations that can be used for this bike lock. So I have choices 0 through 9, and actually there are 10 choices if you count the number of digits here. So let's say these spaces represent my 3 numbers. For the first number, we have a choice of 0 through 9. So there are actually 10 choices for the first number in the combination. The second number also has 10 choices because the numbers can be repeated. And then the third one, there are also 10 choices. So the multiplication principle says that if I list the number of choices for each digit, then the number of combinations is going to be those 3 numbers multiplied together. So that means the number of lock combinations is 10 times 10 times 10, or 1,000 different combinations. Another type of lock might say that the digits cannot be repeated. So I still have 3 numbers in my combination, and the first number would have 10 different choices, 0 through 9. But let's say the first number was a 1. Well, that means I can't use the 1 again. So my second digit is going to have 9 choices. And then those 2 numbers are used, so my third digit is going to have only 8 choices. Then using the multiplication principle again, I can multiply these 3 together, 10 times 9 times 8, and I actually only have 720 different types of combinations if the numbers cannot repeat. And so looking at the technical description of the multiplication principle, it means suppose we have n choices that must be made, with m sub 1 ways to make choice 1. That means m sub 1 ways to make choice 1. In this case, it's 10 ways. M sub 2 ways to make choice 2. Here's my choice 2. And if I list the number of ways, then there are m sub 1 times m sub 2 times however many digits you have in your combination lock. Those are multiplied together. So another way that we can count the ordering of elements is by using what's called a permutation. A permutation counts the number of n elements taken r at a time. And in this case, the order of elements matters. Just like in our combination lock, the order of the combo matters because a combination of 6, 7, 8 is different than a combination of 8, 7, 6. So the order matters. So combo locks are called permutations. The way that we write a permutation is NPR, and I'm going to show you how to calculate it using factorials. Factorials are the exclamation points that you see. So let's say we have 3 students, Joe, Carlos, and Sam, and we want to see how many ways those 3 students can sit in 3 chairs. The order is going to matter. So that means Joe, Carlos, Sam is different than Joe, Sam, Carlos. I count those sequences as 2. So we set this up as 3, which is the total number of students that we have, permutations, choose 3. 3 is n, and 3 is r. And that equals, n goes on the top, so 3 factorial divided by parentheses 3 minus r, which is 3 factorial. So 3 factorial is the same thing as 3 times 2 times 1. The factorial just means that you're going to multiply 3 times each digit below 3, except 0. On the bottom, I have 3 minus 3, which is 0, and 0 factorial, by definition, is 1. So that needs to be memorized. So 3 times 2 times 1 is 6, and 6 divided by 1 is 6. And that means there are 6 different ways that 3 students can sit in 3 chairs. Notice this 3 times 2 times 1 is much like how the combo lock was set up. The first chair, there are 3 choices. The second chair, there are 2 choices. And the third chair, there's only 1 choice. So the next way that you can count is by using what's called a combination. A combination is used when the order of elements does not matter. So in this case, I just want to know how many ways can 3 students sit in 3 chairs. I don't have the names of the students. I just want 3 students to sit in 3 chairs. So if I switch 2 students around, that's still counted as one sequence. So if I was going to set this up using the combination notation, so that is going to equal n factorial, so 3 factorial, divided by 3 minus 3 factorial times r factorial, which is 3 factorial. And what you're doing here is you're dividing out all the repeats. So 3 factorial we know is 3 times 2 times 1 divided by 0 factorial, which is 1, times 3 factorial, which is 3 times 2 times 1. So that gives us 6 over 6. There's only one way that 3 students can sit in 3 chairs if the order does not matter. So the next thing I want to do is show you how you can calculate permutations using your calculator. So in this example, it says how many variations are possible for gold, silver, and bronze medalists in the 50-meter swimming race if there are 8 finalists. So you have 8 people that are swimming in the race, and one person will get the gold, one person will get the silver, and one person will get the bronze. If you switch the gold winner and the silver winner, then that's considered a separate sequence. And so the order does matter. So you'll notice in the notation you have 8 finalists, it's a permutation, and you want to choose 3 from those 8. So in your calculator you would hit the 8 key, and then you need to find the key with NPR. And on a TI-30XA, NPR is the second 9 key. So in your calculator you hit 8, second 9, which is NPR, and then 3, and then equals, and you get 336. There's 336 ways that you can choose 3 medalists from 8 people that are swimming in the race. Now as a combination, that looks like this. How many variations are possible for 3 people to medal in the 50-meter swimming race if there are 8 finalists? Now notice that the gold, silver, and bronze are not specified, so it's just 3 people to receive a medal. So that is an 8 combinations, choose 3. In your calculator, just hit 8, and then the NCR key is second 8 on my calculator. So I hit 8, and then second 8, which is NCR, 3, and then equal sign, and you should get 56. Okay, so just to review the difference between a permutation and a combination. On the left-hand side we have a permutation, and on the right-hand side we have a combination. And so in this case we have 2 soup cans that are chosen from the 4 types. So if we say that the first branch is going to be the first choice and the second branch is the second choice, if you choose noodle and then bean, that counts as one way, one sequence. Noodle and then mushroom is a second sequence. Bean then noodle is also counted. So the order matters. That means when the order is switched, you also count that as a sequence. Over here on the combination side, if the first choice is noodle and the second choice is bean, that's counted as one way. But if the first choice is bean, you'll notice there's no choice here for noodle because you've already counted that up here. So bean then noodle is not counted because if you switch the 2 around, it's considered the same sequence. So 4 permutations choose 2 cans is going to be 12 ways that can happen. And 4 combination choose 2, there's actually only 6 ways because all the duplicates are divided out. So let's try another example. In this one, a financial advisor offers 8 mutual funds in the high-risk category, 7 in the moderate risk category, 10 in the low-risk category. An investor decides to invest 3 high-risk, 4 moderate risk, and 3 low-risk funds. How many ways can the investor do this? Well, we want to think about the order. If I decide to invest in 3 high-risk funds, does it matter the order that they're in? Notice those funds don't have names to them. And if I chose them in a different order, I'm still choosing 3. So because of that, this is considered a combination. So the first thing I'm going to do is figure out how many combinations there are in the high-risk category. There are 8 total funds in the high-risk category, and I know it's a combination, and I'm going to choose 3 from those mutual funds. The next thing I'm going to do is I'm going to choose 4 from the moderate risk category. There are 7 in the moderate risk category, 7 combinations, choose 4. And then in the low risk category there are 10, so 10 combinations, choose 3. So all I need to do is plug those into my calculator and find out how many there are. Now because I'm choosing 3 and 4 and 3, I'm going to use the multiplication principle, multiplying together, and that gives you the total number of choices. So in my calculator I have 8C3, which is 56, 7C4, which is 35, and 10C3, which is 120. Multiplying those together, it gives me 504,000 ways to choose those mutual funds. So try some permutations and combinations on your own, and think about, does the order matter or does the order not matter?